This student asked this question, so let's answer it. Atoms, ions, and molecules are some of the more challenging concepts for a new A&P student to grasp, and there's no surprise to that. These things are really tiny, and it's hard for us to imagine how these things react and interact in our body. So let's take a close look at one element, potassium, which is something that will come up over and over again to help us understand these nuclear terms a little bit better. Now, it's helpful if you've had chemistry, but here where I teach, we don't have chemistry as a prereq anymore, so this video should help you get by. Now, the elemental symbol for potassium is K because K represents the Latin term kalium. The nucleus of an atom is made up of positively charged protons and neutrally charged neutrons. I intentionally used red and blue to remind us that they make up the nucleus. Now, potassium has 19 protons. That is called the atomic number. There's one more part of an atom, and that is called the electron, and electrons have a negative charge. Now, in a neutrally charged atom as a whole, the electrons will match the protons. Now, what I'm drawing here is something called a simplified Bohr model, and a Bohr model is really helpful because it helps us to see how the electrons will interact with other atoms. And these little circles here are called electron shells, and they represent different levels of energy basically. And so the electrons will be drawn in each shell, and you always start closest to the nucleus there. And that first shell is always going to get 2 electrons, as you saw me draw there. And now I'm adding more. Each subsequent shell is going to get 8. Now, as you get bigger and bigger, there are other shells that will have a different number of electrons, but for the purposes of this video, they're only going to get 8. So you can see me drawing more electrons there. But in this last shell, or the outermost, which is called the valence shell, there's only 1 electron. Pause the video and count how many electrons. There should be 19. Now I'm going to draw a chlorine atom right next to it because I want you to understand exactly why we care about these electrons. Chlorine is in the 3rd period, therefore it has 3 electron shells, and we're going to fill it in just like we did the potassium atom. So the innermost electron shell gets 2 electrons, and then we're going to fill in 8 for the second. But as we get to this outermost shell, or the valence shell, I want you to notice, how many do we put here? Only 1 on that side. So pause the video and count the electrons. Hopefully you came up with 17, which is also the atomic number for chlorine. Now, when we have single electrons in the valence shell, they don't like to be alone. And so what can happen is they will try to pair up with another atom so it can become complete. What this means is that the outermost electron in that valence shell is going to try to pair up with the outermost electron in the chlorine. And this will create an ionic bond, an ion because we have a positively charged ion, which is potassium, making a connection, so to speak, with a negatively charged ion called chlorine, but when it's in that ion form, we call it chloride. And so now these 2 atoms will come together to form potassium chloride. So what are the indications for this for an A&P student or future healthcare practitioner? Well, potassium chloride is a common way to treat hypokalemia. Remember, hypo meaning low, kalemia refers to potassium levels in the blood. As you continue through anatomy and physiology, you're going to see potassium related to all of these plus more. The main point is that when you're studying physiology or pathophysiology, your familiarity with these terms like protons and electrons will make it so that you aren't afraid when you see these reactions happening in the body. Let me know in the comments if you have any questions or comments, or if you have any requests for other video content, and I'd be happy to make some. Happy studying!